guys and welcome today. So we're looking at an FP1 specimen paper, and this is the AS part of the paper. So if you're looking for the A level, this might be a bit too easy, but it could be worth looking at anyway. So let's have a look at it. There's 5 questions in total. So question 1 here is a T substitution or a T angle formula, or even half angle, whichever you've known it as, style question. So part A, we're asked to show using the substitution t is equal to tan x over 2 that sec x minus tan x is identical to 1 minus t divided by 1 plus t. So that's for 3 marks. So what's the easiest way to do this? Well, we need to write this in a form where we can start using the substitutions. Now, sec x we don't have one for, but remember sec x is 1 over cos x. So if we write it like that, cos x we can use, so we can put it into that form. And then we can use the substitution, so minus tan x. Now this, well, cos x, remember, so the substitution for this is going to be 1 minus t squared divided by 1 plus t squared. So what this is now, because it's 1 divided by, it's going to be 1 divided by 1 minus t squared. So here now we're just using the substitutions, so it's 1 minus t squared divided by 1 plus t squared, like so. And tan, so remember tan x is going to be 2t, so this is minus 2t divided by 1 minus t squared. So a little bit easier to remember, 1 minus t squared. So remember, these aren't given in your formula books, guys, so you either need to just memorize them or learn how to derive them. So these are the appropriate ones for this part. Now we just need to do a bit of manipulation, and it's just straightforward from here. There's no more formulas that are used or anything like that. It's just manipulation. Oops. Start that tonight. So sorry about that. So if we manipulate this now, this 1 plus t squared here will go to the top, and it's going to times by whatever the numerator is. So because it's 1 times that, that's going to become my new numerator. So what I've got now is 1 plus t squared divided by 1 minus t squared. So all I've done is manipulate this here, minus this quotient here, nothing's changed here, minus 2t. And notice the perfect thing now is we've got them over a common denominator. They're both 1 minus t squared. So that's going to give me 1 plus t squared minus 2t. So what I've got is t squared minus 2t plus 1 all over 1 minus t squared. Oops, 1 minus t squared. And now we can simplify this. What we know is that we're going to end up with a 1 plus t in the denominator. Now this is difference of 2 squares. So we don't know what the numerator is going to factorise as just yet, but we know the denominator will be 1 plus t and 1 minus t. Because the 1 minus t clearly must cancel, because this just gives us 1 plus t in the denominator. Now, if the 1 minus t cancels up here, we must have at least 1 minus t, right? So we can eliminate them too. But what do we times this by to get this? Well, to get this now, 1 minus t times something gives me this. This is clearly got to just be 1 minus t again. This would be 1 minus t squared. And now we can cancel. So what this is going to give us, if we cancel one of them, this is clearly identical to 1 minus t divided by 1 plus t. And there we have it. So we've cancelled 1 minus t in both the numerator and denominator to give us 1 minus t divided by 1 plus t, like we needed. So that's the first 3 marks there, nice and easy. Now for part B, very similar again. We're just using a substitution again. So this is 1 minus sine x divided by 1 plus sine x is identical to sec x minus tan x. So notice this is sec x minus tan x. So this is going to be useful, the part A bit, to give us a bit of an answer to part B. So first let's use the substitution for sine x. So 1 minus sine x, so 1 minus, so remember for sine x the identity is very similar to your tan one, but instead of 1 minus t squared it's 1 plus t squared. So it's going to be 1 minus sine x will be 1 minus 2t divided by 1 plus t squared divided by 1 plus sin x, this is going to be 1 plus 2t divided by 1 plus t squared. Now here, we have to be able to manipulate this. So what's the easiest way to manipulate this? Well, notice we've got 1 plus t squared in both here, in this part of the numerator and this part of the denominator. So the easiest way to deal with this and simplify would be just times top and bottom by 1 plus t squared. So if we do that, what that's going to give us is 1 times 1 plus t squared minus 2t. So it's going to be 1 plus t squared minus 2t divided by, again, 1 times 1 plus t squared plus 2t. So it's going to be 1 plus t squared, but instead of minus 2t, it'll be plus 2t plus 2t. So we're getting there now. We're actually closer than we need to be already. So now we need to factorise both of these. So notice 1 plus t squared minus 2t is this expression here. So that is going to clearly be 1 minus t squared. And notice, so think back to what this is saying. This is saying that this is sec x minus tan x squared. So if you were to square this, so if I do it in black, so if you were to square this, that'd be the same as taking the numerator squared and the denominator squared. Well, we've got the numerator squared here already. So what we know is at the bottom should give us, if you factorise it, let's change that back to y, it should give us 1 plus t squared. So if you were to factorise this, would it give it? So yeah, exactly, it would, right? Because if you pick the ones out at the end, it's going to give you t plus 1 or 1 plus t, which is identical to 1 minus t 1 plus t all squared like such, which is identical to sec x minus tan x squared. And there we have it. We've got it, because we've just shown using the substitution for sin x that it does factorise quite nicely. So that one's probably easier than part A, but hopefully it's quite a nice standard approach to a T formula question. If you've got any questions, be sure to leave them below, guys, but I hope that's okay.